Hello, welcome to Beginners Python and Machine Learning. My name's Tim Cummings. We're a meetup group and trying to help people get into Python and also look at some machine learning topics. This is a live session, so the advantage of that is you can ask questions as we go. You can ask them either in YouTube chat or you can ask them on Slack in Learning to Code. And the details for getting in contact with the Slack group are below this video in the comments or on the meetup site. Now, I'm not sure if everyone else is getting this message, but yeah, the sponsors, our sponsors, I think, have stopped paying for our meetup group. So it's saying we need an organizer. So I'm not sure what's going to happen, but keep an eye, listen to the Slack group or our GitHub site if you want to find further information. I think this meetup group might be ending on the 28th of December. But anyway, tonight we're going to be looking at Google Colab, which is a fantastic way of learning Python, and it's really convenient for people doing data science, and so you don't even need to install Python on your computer. Now there's a link here just below the video to a Colab notebook that I've created, and so if you click on that link, and it's also in the meetup description, you click on that link, it will open up a Colab notebook for you. Okay. Now, see, it says changes will not be saved. That's because you are looking at my notebook. But if you just click copy to drive, you get your own copy, in which case you can make changes to it and save those changes in your own area. So click on copy to drive, and we'll go through some of the things that Colab notebooks can do. So I'll close this one. I've turned this one off, private output, so will not be saved. I like to do that so we can see for fresh every time what's been created. So we'll just hide that message. Release notes, looks like a new Colab's come out recently, and there's a VS Code extension which I gave it a go, and it's pretty slow, so I wouldn't bother with that. Alright, so let's close the release notes. Okay, so this is a Colab notebook, and it's made up of a bunch of cells. So you can see each of these cells. That one's got a line around it. If I click on this one, then this one's got the line around it, the border. And if I click in between them, I can add in a new cell, and it can be either a code cell or a text cell. So we're going to look at some of the things that we can do in these code cells and text cells. We're going to be using a runtime. So if we go to change runtime type, you can see some of your other options, but we'll just take the default one. So we're going to be running Python 3 with just a CPU. Now if you're doing some machine learning stuff, you might find you'd want a GPU, and that will give you some better performance. And these ones are available on the free version of Colab, and then if you want these other ones, you need to get the paid version. Alright, so I'll just cancel that. So what Colab is it's running Python on a virtual server that Google has set up just for you. So let's hit connect up here in the top right to get that going. That'll start up the server for us, and you can see it's given us some RAM, 12 gigs of RAM, which we're using 0.9, and 107 gigabytes of disk space, which we're currently using 38. And so when we've finished, we'll just close our tab in the web browser, and eventually that server will time out and just delete itself. So nothing will be saved on the server, but the stuff that you've been doing, changes, will be saved on your own Google Drive. So it's good to have a Google account to run this. Okay, so these are our learning objectives today. Python in Colab, Markdown in Colab, command line from Colab, third-party libraries, and the file system. So I've also put here links. This is a link to this notebook. And also we've got GitHub. So you can always go to GitHub and see all our past sessions. So that's quite useful. And we'll probably put any news that's on GitHub as well as on Slack if we happen to lose our Meetup account. So let's talk about Markdown first. Markdown is a way of editing the text cells in Colab. So the text cells is just a way of writing text. It's a superset of HTML actually. Most people don't realize that. So you can just write straight HTML. Now if I double click on this cell, it'll show me how I created that cell, which is this using this HTML, and I've created a nice table there. And then on the right I can see what it looks like. So it renders it. And you can make changes, and you can see that it dynamically updates with dynamic updates. And you see over here on the right, it takes those updates dynamically. But really we've just shown how to do a table with 2 rows. It's got this row here with headers and this row with just normal data cells, and this is what it looks like. And then I've drawn a horizontal rule at the end. Now Markdown is really a bit of a play on words, because HTML stands for the hypertext markup language, and they thought, well, markup sounds too hard, so let's go for Markdown. And so they made the Markdown language, which does a lot of this stuff, but with an easier one to remember. So this could be using all these angle brackets, and tag names can be difficult to know or remember. So to do it just using Markdown specifics, this is how you do it. So we've got a heading here. So we do 3 hashes for a 3rd level heading, and then we put in our header row, and then if we put these dashes, then Markdown knows that that's a header row, and then everything below that is just data rows. And then if we just do 3 dashes on their own, we get a horizontal rule. And you can see over here on the right what it looks like. Now, I'm not going to spend a lot of time on Markdown, just letting you know it exists. So if you need to document your notebooks, you can do it in a way that actually looks reasonably good. So that's that one, and then we've got this one, creating Python cells. I showed you that. We got the code cell or the text cell. So the Markdown is in text cells. Now Markdown can also, the Markdown in Google Colab can also use LaTeX, which is really good if you want to do formulae. So these formulae here I created using LaTeX, and I've just given you a reference link here on how to do these, but you can double click on it and see how I've done it, and that's what LaTeX works. And LaTeX is pretty popular among uni students for when they're documenting their maths or science or engineering PhDs, or theses. They use LaTeX all the way through to put in all the formula, and it looks quite good. And that's another thing that Markdown can do. Images are slightly tricky in Markdown, but remember you can always use HTML, and there's the HTML to show an image. Alright, so that was a quick rundown of Markdown. Now let's have a look at some Python. So when you create a code cell, it'll look like this one down here, and you can start typing. And because we've set a Python runtime, it means that it expects the code to be in Python, and it will do syntax coloring as though it's Python, which means if we put in comments, they come up in green. If we put in variable names, they're in black, and literal values are in blue, and function names are in brown, just as an example. So here's a little Python program we've typed in. We've typed in 2 comments. Python knows they're comments because they start with the hash symbol. So anything with anything after the hash is a comment in a Python line of code. And so I've written that comments in code cells start with a hash. And this is a short program to show how to store a value in a variable. So we've created a variable which is like a memory location in Python, and we want to put some data in there, and then we want to have a look at it later and see what that value is. So we're taking the number 5, we're putting it in a memory location that we've called A, and you can call it any name that starts with a letter and is just made up of letters and numbers. And then we want to display what is in the value of that memory location, and we use the print function to do that. So if I run this bit of code by clicking on the play button here, it will store the value 5 in memory location A, then it will display the contents of memory location A here in the output, which is down here. And you can see it's printed out the value A. Now those values in variables are remembered between cells. So that's a pretty important feature of Google Colab and notebooks. So because it means you can step through the code and it stores the results, and it keeps remembering it for the next, when you run the next cell. It says now Colab is running a thing called IPython, which is interactive Python, and that's really the secret to why it remembers between cells. And normal Python, once you've finished your script, all data is forgotten. So remember A, we stored the number 5 in it. If I said, well, let's calculate A plus 6, it'll take the value of A, which is 5, it'll add 6 to it and display the result, and we get 11. Now there's another difference between IPython and Python. So in normal Python you would have to say print A, but in IPython you just have, I could have just said A and it will have displayed the result. And in this case I've said A plus 6 and it displays the result without having to use the print function, which is, the result is 11. And that only happens on the last line, but it's quite useful and saves a bit of typing. So one of the most important things when using a system like this is how to get help. And help you can get, you can go up to the help menu up here, but you can also do it in a cell, for example, by typing in a question mark, and that will bring up the IPython help. So if I run that cell, you can see it opens up this window pane over on the right that tells us all about IPython, the interactive Python that comes with Google Colab. And it tells us what we can do. We can use question mark to get help. We can use question mark after an object, like so print would be an object. Function, all functions and classes and stuff are objects, so you can do a question mark under them and it will give you some documentation on that function or class. There's also a thing called magics which come with IPython, and you reference them using the % symbol, and %quickref will give you a reference to some IPython specific magics. You've also got help, which is that Python has, normal Python has, and that will work as well. But it will give you the help over here in the cells rather than opening up this new pane over here on the right. So if you keep scrolling down, you see all sorts of things that you can do and explanations of IPython. That's pretty useful. There, I've summarized that in this next cell. Okay, so let's have a go. I've set a task up for you. How do you get help on the print function? So there's a blank cell. Have a go at typing in how you would do that and see if it works. Now you can pause the video because I'm about to go straight into the answer, and unless you've got it already. Now here's the answer, solution 1. You type the object, print, and then you put a question mark under after it. And if I run that cell, you'll see that over here on the right, it's brought up help for that function. Now so I'll show you what would happen if I'd done it the Python way rather than the IPython way, because all Python stuff works here. I could have said help print, and I can run that, and it gives me pretty much the same thing. Alright, task 2, search the IPython quick reference. Okay, pause the video and have a go at that, and then I'll go straight on. So remember, we were looking through this help over here, and it told us up the top here that there was a way of getting a quick reference, which was %quick_ref. So let's try that. Solution 2, I've left a cell for you to try it, but here's the solution. Let's try it, and that's pulled up another help card, which is the quick reference card. So that gives us a few help things. It talks a bit about aliases and magic function calls. Also tells us how to run command line system commands and other things, and all these ones with percents in them, they're all magics. Okay, so we've done that selection 2. Task 3, search info on IPython's magic operator and find how to do cell-oriented timing. Okay, well, if we keep looking down through this quick reference, we'll see here magic, print information about the magic function system. Alright, so let's run that. %magic, and that's brought up another window over here and talks about magic, and it says that oh yeah, and we want to find cell-oriented timing. Okay, so this looks like what we're after. Line magics are prefixed with a % character. Okay. And then cell magics are prefixed with a double % sign. So if we use a single %, then we can do a magic on a particular line. So if we wanted to find the range from 0 up to 1,000, we can time that, and that will just time the line. Or we can do a double %, and that will do the timing on the whole cell, which is everything included in the boundary here. So task 3, time how long it takes for Python to calculate the 100th power of x when x is 2 to the power 100. Okay, so we want to use a cell-oriented timing. So we time at x equals this number here, and then we're going to calculate how to the 100th power of it and time that. Now okay, we'll type that in. So we type %, time it, and then we set so you can see here where it sets x, that's called the setup, and that's not included in the timing. So assigning x to a value, x equals 2 to the power 100. I think that's what I want, 2 to the power 100. And then we want to calculate x to the power 100. And we're going to time that calculation. So the first line is not included in the timing, just the rest of the cell. So it's calculating it. Now it takes a while because it actually does it more than once, and that way it gets an average over many times of doing it, which is more accurate than just doing it once, because sometimes things can happen. So it actually did it 100,000 times, and it took 17.4 microseconds plus or minus 4.3 microseconds per loop. So that's the mean and standard deviation. And so it did it 7 runs, and each run had 100,000 loops. And that's the same as my answer that I had here previously. Okay, task 4. From the quick reference card, work out how to determine the underlying operating system using the OS command cat/etc/os release. So the quick reference card was this one. No, this one here. Yep, the quick reference. And we want to run a system command. So if we scroll down here, we can see system commands, and they start with an exclamation mark. So we've been given the system command that we want, which is we want to cat that value, that file. So cat means type out the contents of the file, which is useful if it's a text file. And we want to run it as a system command, so we put an exclamation mark to start with, and then we type it in, and then it tells us what's in that file. And here we can see that the virtual private server that Google has provided us with is running Ubuntu version 22.04. So that's nice. And once again, there's my solution, which should give me the same thing. We can also find out what version of Python is running on our server. So it's version 3.12.12. So we did that by using the system command. We could also do it using the Python command, which uses the sys library inside Python. So here's Python statements. This one here is a command line statement in the probably bash shell. And as expected, it came up with the same answer, 3.12.12. How much memory has been allocated? So we can do all these system commands, and we can see we started with 12.9 megs, and we've used 975 kilobytes, and well, it's actually no, they're gigabytes. So so free -m means do all the numbers in megabytes. So they've given us 12,975 megabytes. We've used 978, which and we've got 8,505 free. And then because of caching and memory, there's even more available. It's not all exactly free. So these numbers here agree. If I hover over here, it says RAM 1.29 gigabytes has been used, which is not sure, 1.27, 1.26. So he's changing all the time, but it's this used value. Maybe let's run it again, see if it still says the same. No, it still says the same. Anyway, different memory systems can be measured in different ways, but it's roughly the same. How much storage space? So we do disk free in human readable format, and it says that we've been given 108 gigabytes, of which 3940 has been used, and I don't know what this kaggle input is, but it must be some extra kaggle data that's been saved. But yeah, so it says we've got 107, which we use 38.13. So they sort of agree. We want to see what shell we're using. I think it's bash, and it is bin/bash. What's the name of the user that's running the shell? And it's root. And you can even upgrade the software on your virtual private server. So update says find out what updates are available, and upgrade actually installs them. So we're doing an update. It says there's 59 can be upgraded, and so then it goes and upgrades them. So it's pretty impressive. Like, you get a fair bit of control over this virtual private server. I'm just going to close all these helps. So it looks like Python 3.10 is also installed on that server, as well as 3.12. We've got Java as well. Looks like it's finished. All right. So that was the updates. What else can we do? We can decide what version of pip. So pip is the program that we use for installing third-party libraries for Python, and it's currently running pip version 24.1.2. And we can also use pip to say what third-party packages have already been installed. And you can see there's quite a lot of them. So it's pretty similar to the ones you'd get if you were running Anaconda on your machine, but then Google actually throw a few more in there as well. So it's quite extensive. I prefer not having them all installed myself, but anyway, they're there. So it is easier to use them if you don't have to install them yourself. You can upgrade them if you want. So for example, Pandas is currently running version 2.2.2. So it's a bit dangerous upgrading them, but you know, if you do an upgrade and it doesn't work, then you can always just start a new runtime with it out being upgraded. All the ones that are currently installed have been tested by Google. So let's try to upgrade Pandas and see what happens. So it's found 2.3.3, so it's going to uninstall 2.2.2 and install 2.3.3. And it's already... Okay, and it tells us we need to restart the runtime if we want to use the newly installed versions. And that will lose the state, including local variables. So let's give that a go. We'll restart our session. And you can see that's been restarted. Now if we run this one here, we'll see what version of Pandas is installed. And 2.3.3, and let's test what the value of A is. our memory location, and it said A is not defined. So it's forgotten any variables that we created earlier because we restarted the runtime. So that was how to upgrade a session. You can also install new packages that might not be installed. So XLSX Writer is one. So that's a useful package if you want to create XLSX files for Excel using Python coding. And we've actually got some sessions on that if you want to go through our GitHub and find the old sessions on how to use that library. You can even install packages straight from the source. This can be done on normal Python as well. So it's just always good to know that if you can't just type in the standard pip command, which has the software has to be installed on the pipi repository for this to work. But if it hasn't been put up there, then you can actually just go straight to the source. And in this case, we're going to go to Facebook Research and get Detectron 2 from the GitHub repository. So you can see it's going to the GitHub repository. It's cloning it locally. It's then going to the latest version, and it starts to install. It works out what other libraries need to be installed, and it goes, well, these ones are already satisfied, this one isn't, yak, so it's going to download that and install it. Similarly, FV Core it needs to install, Hydra Core Black has to download and install. So it's doing a lot of work there. It's building the wheels for all of them. So sometimes that even will compile if you've got C code included in that along with your Python. And eventually it will install it. So let's move on while it's doing that. If a library can't be installed using pip, then you can use the Ubuntu Package Manager APT. Here's an example of a package which could be installed either way. So the deprecation package, you can install it either using apt install Python 3 deprecation, or you could use pip install deprecation. If I try running it now, it'll go, it's waiting for the previous cell to finish before it will start. So that's good. So that's what that revolving circle is. And then once it's installed, we can get this one to run as well. So we can queue them all up. So it'll run them in this order. And we look down at the bottom right hand side, we can see that that cell's been executing for 2 minutes and 3 seconds. So it's quite a big build to build up Detectron. So it's built it, and then it's given us a success message, and then it can run this next cell, which is installing it using APT. These days, pip is pretty good. You rarely need to use APT anymore, but in the early days, pip didn't have had troubles with a lot of packages trying to install them, and so by using APT, you're using ones that the Ubuntu or the Debian maintainers had worked out how to build it, and they'd created a package specifically for them, for their operating system to use. There we go. That's installed deprecation, and then this cell ran as well because we queued it up, and so we did a pip list, and then we filtered it using this pipe symbol. What that does is it takes the output of this command and feeds it into the input of this command, and what this command does is it looks for the word deprecation and if it's not in a line of text that's come to it, it ignores it and will only display the lines that it's got. So in that way we're able to filter the output of pip list to only show the lines that include the word deprecation, and there it is, version 2.1.0 has been installed. And that means that now Python can import it. So we can type in import deprecation and that cell works fine. Doesn't do anything that we can see, but it ran without an error, so that's good. Now, can install Ubuntu packages to augment the default Python. So for example, we might want to create virtual environments. Actually, I've got version 3.11 here. I should have 3.12 because that's the Python that we're running. We need to install that. Then we can create a virtual environment, and unfortunately that if we make it active, it'll only stay active for this line, but we can put more than one command on a line by using the semicolon. So let's try that. And that's because we're using these exclamation marks to do a line. So it basically creates a shell, runs the line, and then stops the shell. And then the next line creates a shell, runs a new line, and then stops the shell. So these work because they create stuff on the drive, but the next line, if we did source, that doesn't create anything on the drive, it just does something in the shell. So that's why we need to do that before we can run pip. We need to run pip list on the same line as that. So let's give that a go. So apt installs, what's happening first? It's going fetching it. It's using the Dead Snakes PPA, which is a one created by the Python people, to install VENV, and then it sets it up, and then it says our version is pip 25.01. Yep. Pip list. Oh yeah, and this is the list. That's the full list. And remember before we got a lot of stuff in the list, but now we've just got the one package in that list, and that's because we created a brand new virtual environment. So virtual environments are fantastic for keeping stuff isolated and keeping a very clean environment, so you don't have any unexpected interactions from other third-party libraries that might be installed. Alright, so when we go to our reference cards before the help on magic functions, there was one for bash, and that allows Colab can run a bash script. So we say what's following is a bash script, and my script is going to do this, which is creates a 2-line file and puts it in a file name called hello world, and then it runs that file. So let's try that. There we go. It's created the 2-line files. That's because we use T, it shows it on the display as well as saving it in a file, and then it runs it, and it says hello Python and then the version number of Python. So that's a way that you can get several lines of code to happen. We could probably have used it in to do source of our virtual environment and then list the source. But then now there's a new one. The pro users have had it for a while, but now it's available for free users, and that's the built-in terminal. And so you can see down here in the bottom there's a terminal button, and if I click on that, and it'll open up a terminal here. So if I say ls, it shows me what files are in my file system, and you can see there's the hello world.py that we just created. There's the virtual environment files that we just created, and this sample data is just some sample data that Google Colab give us, so that we can use in it. We're doing some data and data science analysis, and we're just doing testing, so they give us some sample data to play with. All right, so let's try some of the things that we had before. If we did a pip list over here, we can see that we've got access to all the third-party libraries that were installed. So can we activate the virtual environment that we just created? So let's have a look. My venv bin activate. And this is how you activate one in Ubuntu. You use the source command, and it's been activated. So it's telling us at the beginning what the name of the virtual environment is, my venv. And now if I do a pip list, I can see that it's a very clean version of the environment. And in fact, if I look back in my previous pip list and look for pip, I can see that it had an old version of pip, and now I've got, in this virtual environment, I've got a new version. So yeah, I can test different versions in different virtual environments. Okay. I wonder, when I was seeing that version 3.11, see if Python 3.11, no, it's not actually installed. So I'm not sure why it was installing that stuff before. What was it, 10 maybe? Yeah, so Python 3.10 is actually installed. And Python 3.12 is installed. Now let's see if Python 3.13 is installed. No. Alright, to get out of that, I think exit probably works. It disconnects, and then we can close the window. So that's great that the free users of Colab now get access to terminal. Right, so next we're going to do a couple of data science exercises. So we're going to get some data from Kaggle. So how do we do this in Google Colab? Now Kaggle requires an API key, and I've got one sitting in my Google Drive. So this is my Google Drive. If I look in the drive, I haven't got much in here, but I've created a folder called Kaggle, and in here there's my Kaggle file, which is just going to have the API in it. I think this one will be a demo. I could probably open that. And this is what the format of the file looks like. It'll have a username, and it'll have a key, and the key won't be my Kaggle API key. It'll be some combination of letters. All right, so we want this one, kaggle.json. It's a JSON source file, but that's in Google Drive. How do I get access to that in Google Colab? Well, it turns out all I need to do is I can run this bit of code here. There's a third-party library from Google called google.colab. I can import Drive, and then when I've got Drive, I can say mount my Google Drive in Google Colab. So let's run that. And it says, it now asks me, it goes, well, this code's doing something dodgy. It wants to get to your Google Drive. You happy with that? And we'll say, yep, connect to Google Drive. Choose which account. So we'll choose my Pythonator account. And it's going to get access to Google Drive. So this is the files that are Colab has access to. And we wait a bit, and there it is. Now G Drive is now available. And if we look in G Drive, we can see my drive, Kaggle keys, and kaggle.json, which was what I showed you. It was in my Google Drive on my PC. So now that that's there, I just have to tell I just have to tell kaggle that that's where it is going to be, and I can import kaggle. So I've done this. I've created effectively an environment variable called kaggle config directory, and kaggle, when you import kaggle, it will see that environment variable and know where to look. So let's do that first, and now we can run it. We can run the kaggle command from it's a system command. It's not a Python command, so we need to prefix it with the exclamation mark, or we could do those other things like run it from terminal or run it in a bash cell. For client error forbidden for the URL. Okay, and that's going to be because my API key has probably expired. So let's just have a look. Alright, I'll just see if I can get another key. Otherwise we're going to be cutting this session a bit short. Welcome Pythonator. Let's see. API, generate a new last use time. Okay, let's generate a new one. Beginners Python and machine learning. And that'll create it. So I'm going to delete this one straight after this session, so can't use that. But let's create the token. I may as well let you see what I'm doing, because I'm going to delete it straight afterwards. Looks like they've got a different format. Maybe it's been a while since I've used this one. And we'll give it the name. Well, that might do. And I'll just rename this one. Yeah, it looks like they've got some legacy ways of doing it. So let's go back here and run this. and see if that's used the new key. It hasn't, but let's restart the runtime. And run all. Let's try that. Oh, I probably didn't need to run those slow ones, did I? Let's try stopping it. Disconnect and delete. And then we'll start, reconnect. And we'll just start here. We've got to import Google Drive. And see if that works any better. Unauthorized for URL. Okay, well that's not working, so let's, because they must have a new format, so let's just put the API key straight in. And let's see what they said. Let's create a new one. Kaggle API token. All right. So this line here, let's try that. Still not allowing us. But I think if I can restart the session, because it's when you import Kaggle that's the important thing. The environment variables have to be set right. Okay, thanks for the comment. It's good that I've increased your interest, and yeah, I look forward to hearing what some of your ideas are. I'm sorry, I don't know. OS error. So it wants config directory. So let's do it. We'll do it here. We'll get the data. We'll use the other thing that we've learned, which is we can do a bash shell, and we'll use this code. And then see if we can download it that way. Called process error. That didn't work. So let's try putting it in terminal. Sure, they just said that's all you needed to do. Set the API environment, and then you can use the client as follows. And it keeps looking for kaggle.json. So maybe the kaggle that's on did we install it? The kaggle that comes with Google Colab needs that config directory, but the config directory they've changed the format. Well, let's try create a legacy API key. Okay, it's got to be in that format .kaggle, and this is, and there's the file. So let's put that one over into let's put that one into Google Drive. Replace the file and the destination. Okay. And it wants it to be in tilde.kaggle, kaggle.json. And we'll copy from G drive, my drive, kaggle, kaggle.json. Just make this wider so you can see what I'm doing. And we'll copy that into tilde/.kaggle directory. Okay. And let's try downloading now. And it's not working. Okay, so I'm not sure what's going on there. We're not now we're in the client error. So it looks like the legacy kaggles don't work with the doing that command of downloading. So what else have we got? So we can't do that. We can't unzip it. It's all to do that. All right, we'll have another go, see if we can get this. So we want to get the bulldozers data set. So it's in competitions, and the name of the competition is Blue Book for Bulldozers. and we want the data, and we want to download that. And once it's downloaded, which file do we want? Unzip it, find it all, and get trainandvalid.csv. Okay, trainandvalid.csv. I agree. Okay. You must phone verify your account to perform this action. Okay. Okay, let's try this. All right, so it's saying that I can't get it because I've got two accounts and they've both used the same phone number. Let's see if I can get it with my other account. So I'll try again. We'll get the data. I want trainandvalid.csv. I can do download all. Okay, we'll stick this on G drive. So that's in my downloads. Okay, and we've got a hint here. You might store the JSON locally but not sync to G drive yet. Okay, I think we've abandoned the use of JSON anyway, and it was probably to do with the phone thing that it wasn't working. So it was working out that I had two accounts, but they both had the same phone number, and so it wasn't letting me use that second account. Because I've got an account that I use for all these beginners Python sessions. Alright, so now if I look in my G drive, my drive, and it's got quite a big file now, which now has to be uploaded, and there it is, Blue Book for bulldozers. Okay, so let's copy that across into the content directory. My drive, Blue Book for bulldozers, to dot for current directory, and we look over here on the left, see if it arrives, and there it is, Blue Book for bulldozers. And now I can run this command, unzip it, and that's created this folder here. I can close all these helps, I don't need them anymore. Oh, that closed my terminal as well. Anyway, I don't need it. Now I can do an ls to see what files are there, and this is the one I want, trainandvalid.csv. We can look at the first few lines of that using the head command. There's the first 10 lines. So you can see what it looks like as a CSV file. Now with Pandas, we can read in the CSV file into a data frame. And then we do df.head to display the data frame, and it just displays the first 5 rows of our data frame. So you can see that's how it's grabbed that kaggle data and put it into a Pandas data frame, start doing some data science on it. And that's it. So that was really what that exercise was, showed you how to get some data from kaggle. Turned out harder than I expected, but we got there in a roundabout sort of way. So I've just got some comments here. To run PyTorch or neural network training, you often need better than the CPU provided by the default VPS, virtual private server. So go to the runtime menu, and I showed you that before. You can select GPU rather than CPU, or you can pay extra. If you do select GPU and you're not using it, you'll get annoying messages telling you that you are not using your GPU yet, because they really don't like you hogging resources if you're not going to use them. Okay, well, I hope you learned something from that. It's good when things go wrong because people will see how to solve the problems. Unfortunately, it was something that I can't actually show you all the details, but hopefully I showed you enough that if you come across the same problems yourself, you can have a go at fixing them. So no questions on YouTube chat or Slack. This will probably be the last session for the year. Next year we're trying to organize an in-person event in January, but I'm not sure how that's going yet. We've got in contact with Amazon Web Services and they're being very helpful, but we just need to make sure the venues are available. Okay, I hope you enjoyed it, and until next time.